Okay, one of the questions on the AP Stats exam is always about inference, probably a significance test. So in this video, we're going to look at that question from 2023, and then we can take a look at the scoring guideline to see how you would do if that was the question. This sucks. This is a terrible intro. Get ready to state, plan, do, conclude, because I'm talking about inference, baby.
Yeah, I'm talking about Mountain Dews, baby.
I can't come up with a good intro, clearly. Okay, the 2023 significance test question is lengthy, so I'll give you some time to read it. Actually, why don't you just pause and read it yourself? Now, if you've already been reviewing which test is which, you know that this is a paired t-test for means. It sort of looks like two different samples because we're comparing like placebo to omega-3. However, it's actually a paired test because in week 1, everybody takes, one or the other. They take a week off, and then in week 3, they all switch. So they're paired with each other. So even though it seems like we're comparing two different groups, we're actually just comparing one group with themselves. So paired t-test. Now we can see from the graph, the irritability scores did seem to decrease a little bit with the omega-3. So that's good. And then you can see at the bottom, they've got the differences. So for each person, they took their placebo score minus the omega-3 score and plotted them. Okay, so they're asking us, is there convincing statistical evidence to support the researchers' claim, which was that the omega-3 supplement will decrease the irritability scores? Anytime you're doing an inference question, you should stick to whatever your teacher used as like a structure for inference questions. For example, I usually use state, plan, do, conclude. That's what's in all my videos. I think there's maybe better, more updated versions, but I'm stating, planning, doing, and concluding. Okay? So starting with the state step, we need to say what our null and alternate hypotheses are. So our null in this case would be that the true mean difference is 0. So I'm going to use mu because we're looking at the mean of the entire population. My alternate is what the researcher thinks is true. So he thinks that it's going to decrease the irritability score. If I look back at the graph, it shows me that they're taking placebo minus omega-3. So if the supplement is decreasing irritability, that would mean that the mean difference is going to be bigger. Yeah, because the placebo irritability would be higher than the omega-3 irritability. Now we do have to state what we're talking about here. So after we've stated the null and alternate, I'm going to write where mu d is the true mean difference in irritability scores for the whole population. Also, make sure that your null and alternate are not about x bar. You don't have to do a test to see if x bar is something. You know what x bar is. We don't, however, know what mu is. So just make sure that your null and alternate are never about x bar. Okay, on to plan. We are going to do a paired t-test for means. This is the step I always forget, despite teaching AP statistics for like a decade. You do have to say what kind of test you're going to do, especially on the AP test. We're going to check conditions. So I don't think that people were randomly selected. We had volunteers. However, they were randomly assigned, which is important. It tells us that, the people didn't choose which treatment they wanted to get. And then the other thing I have to check is the normal condition. Now, normally with means, I check to see if the sample size is bigger than 30, because if it is, I can use the central limit theorem to just say it's approximately normal. But in this case, the sample size was only 19. So I have to look at the graph. Now, I can't really tell how normal it is from a box plot, but I can tell that there are no outliers because those would appear as little dots. And I can also tell that this isn't very skewed. So for the normal condition, I'm going to say that the sampling distribution of x bar d is approximately normal because the box plot representing the sample shows no strong skew. I'm not going to say the box plot is normal. I'm going to say that it's not skewed. Okay, we've stated, we've planned, now let's do. I'm going to calculate my t-score. Okay, when you look at the first page of the formula sheet, you're going to see underneath section 3, they give you the generic formula for a standardized test statistic, and that is the statistic minus the parameter over the standard error. So they don't tell you like z equals this, t equals this, but they do give you all the pieces throughout the formula sheet and you have to put it all together. So the easy part here is that our statistic is x bar and our parameter is mu. So the top part of this fraction is easy. But now we need the standard error of the statistic. So the standard error of x bar. So I'm going to go to the second page. I'm going to ignore proportions because we're dealing with means. We only have one population here. Remember, it sort of seemed like it was going to be two, but this is a paired scenario, so it's really just one. Now, this would be for the true sampling distribution. We're over here with the standard error of the sample statistic. So this is what I'm going to put on the bottom of my fraction for t. Whew, okay, so I got 3.138 for t. I'm expecting a very small p-value. So I'm going to go over my calculator and do t CDF. Lower is 3.138, upper a very big number. Degree of freedom is n minus 1, so I'm going to do 18. And I got 0.0026, very, very small p-value. Okay, the moment we've been waiting for, it is time to conclude. The probability of getting an x bar of 1.789 or something more extreme if the null were true is 0.0026. This is much smaller than 0.05, so we reject the null and we conclude that there is convincing evidence that the true mean difference is positive. Now, I think I should have added some more context here. I kind of ran out of room. Okay, this is purely just a logistical spacing issue. But I probably should have said the mean difference in irritability scores for all patients with the medical condition similar to the volunteers. If I were taking the AP test, I would probably just copy that whole sentence right from the problem. Okay, let's see how we did, shall we? Okay, these are the actual scoring guidelines for this question. There are 3 sections. Let's start with section 1. Okay, our solution basically matches the model solution. Let's look at the scoring criteria. You get an E on this question if you identified that it's a paired t-test for a population mean by name or formula. I did both. States the hypothesis using a single mean. Did that. States the correct equality for the null hypothesis and the correct direction for the alternative. I don't know. And provides sufficient context for the parameter by including reference to the population mean difference and the sampling units, people with the medical condition, and the response variable, irritability score. I don't know if I mentioned people with the condition. I mentioned irritability scores, and I mentioned it's the population because I said the true mean difference. I said population here. Okay, the elements of component 4 do not have to be satisfied with the statement of the hypothesis. They may be satisfied by work presented elsewhere, most likely in the statement of the conclusion. Okay, well, I actually didn't write that, but remember when I said I should have written it?
I think I should have added some more context here.
Okay, if I had written it, then I would get an E. I think as is, I probably got a P on this question, just being kind of harsh, but I think it's a P. Okay, section 2. Nice. Okay, I mean, rounding is a little different, but that's fine. So our answer matches. Now let's see the scoring. So I get an E if I check the independence condition by referring to the random assignment. Did that. I didn't say the word independent. We'll check the notes. Indicates that the distribution of scores is not badly skewed. Okay, did that. I got the T statistic. I got the p-value. Okay, let's just look through the notes. Not quick. Okay. Okay, I didn't have to use the word independent or independence, so that's fine. I don't think any of this other stuff is applicable to my answer, so I think we're good. And then last but not least, reject the null. Yeah, okay. So if you go with what I said and not quite what I wrote, I think we got it. It's essentially correct if you provide correct comparison of the p-value to the alpha and provide a correct decision about the null and or alternate. So I did that. States a conclusion in context consistent with and in terms of the alternative hypothesis using non-deterministic language. Okay, so for the context you have to include, same as at the start, population parameters, sampling / experimental units, and the response variable. So I think based on just what I wrote, I don't get the points, but what I said, I think I get the points. Okay, so If I had written that thing at the end, I think I would have 3 E's and I'd get a 4 on this question. Without the thing at the end, it's either a 2 or a 3. So the lesson here is don't stop writing because you're out of space. Ask for more paper. No, the real lesson is context is important. So make sure that you are being very thorough in your context. Do all the math, make sure your calculations are correct, and then just go through and make sure you use the correct symbols. You mention the population, you mention like who the study is about. Your answers should never be so generic that you can like copy paste it to a different scenario. It's got to be so specific to the problem you're doing. Oh my God. I'm tired, dude. I need a break. Okay, so subscribe if you want to see more AP review content. Like this video and comment if there's something specific that you would like to see in the future. I'm going to keep doing some more free response questions, and it's time to start thinking about tackling number 6. Oh man, there's so much talking to make these videos. I'm done. I need some water.